Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This video is going to close out our chapter on loops, and I want to introduce the concept of parallel here. Now, in the book, this is kind of an aside. It's an advanced topic, and honestly, it's something that you don't necessarily have to learn at this point in the book. Parallel collections and parallelism is something that we hit very heavy in the first half of part 2 of the book. However, I think it's good to kind of have this idea running around in your head so that you can be thinking about it and how it impacts things. So the idea of parallel computing is normally when you write a program, the program executes one line and then the next and the next and the next in order. And so let's go ahead and let's write a little script. And in this script, I'm going to write a function. This is a recursive function, and it's one that we'll talk more about later on. It's called the Fibonacci sequence. And the way that I'm writing this, quite honestly, is quite inefficient, but I want that. The reason I want that is because it turns out that if you make things so that they're too efficient, you have problems. So the Fibonacci sequence, the standard Fibonacci sequence, starts off as 1, 1, and then every other element after that is the sum of the previous two. And so one way of writing that, we could say, well, if n is less than 2, we get 1. That gives us our first two elements. Else, it's the fib of n minus 1 plus the fib of n minus 2. It's a very simple way of expressing this. It looks just like the mathematical definition. And now I want to evaluate these inside of the loop. And so I'm going to write a for loop, and I'm going to have in the, let's go from 30 to 15 by -1. So I'm counting down, and all I want to do is print line the fib of n. Okay? So if I come over here and I run this, it produces the Fibonacci numbers. This is the 15th Fibonacci number. This is the 30th Fibonacci number. As you can see, Fibonacci numbers get pretty big pretty quickly. But they came out in the order that I expected them. And what really is important here is that the computer was basically doing one thing at a time as it was doing this. It went through and it calculated the value for number 30 by running through and one at a time calculating each of the different Fibonacci numbers, running around. But when I describe this, it's often I imagine as you're running through code, you can point to a line with your finger. It's one finger going from one place to another place to another place to another place and just moving through the code. Now, what parallelism allows you to do is basically to have more than one finger pointing to different places in the code. And this is important because so many of our modern computers are now parallel machines. So the laptop that I happen to be demonstrating this on, to keep it fully busy, I have to be doing 4 things at once. It supports 4 what are called threads. And so if I'm not doing 4 things at once, or if I write a program that's only doing one thing at a time, I'm dramatically underutilizing the computer. And the number of what are called cores on computers is only going up. At the time I'm making this in 2012, your cell phones come with 4 cores in them. And desktop machines often come with 8. There are single chips that have 16 cores in them if you buy in the server line. So really doing things in a single thread just isn't cutting it anymore. And so I want to show you just the easiest way that you can do things in parallel in Scala. And it's by using what are called parallel collections. So as you might recall, this 30 to 15 by -1 is a type of sequence. If we come over here and I just type that in to remind you, by -1, it's a type of a sequence called a range. Okay, so this gives us back the range 30, 29, 28, 27, etc., down to 15. All of your standard collections in Scala have a method in them called par. which you can invoke that way, or you can just say par at the end there. And this gives you a par range. I mean, this is a parallel range. And what's different is that when it does the operations on a par range, it can split them off and work on, so it's possible that it will do the work for 30 and 29 and 28 all at the same time, okay, simultaneously. In fact, it will probably do the work for more than just 3 at a time. It bases it upon how many cores you have in your computer, and it uses some fairly complex algorithms for that. So if we come up to here, and I make it so that this does exactly what we were doing before, but now I'm going to evaluate them in parallel. When I run this, okay, so we start off with the original 15, and that ends right here. And so this is the next set, and you can see something very interesting about this. Most importantly, they're not in order. Okay? In fact, the last thing that was printed was actually the first thing that our loop said to do. Okay? Because when you put these things in parallel, they give you out, they can happen in whatever order things happen to be scheduled, and that is one of the challenges of working with things that are in parallel. However, if I had been, instead of printing it, if I had been yielding it, and then print out the results of that, I will still get the values in their order, but they weren't necessarily calculated in the order that they appear in the result. Okay, they just, the order they appear in the result matches the order that they came in, but that's not necessarily the order they were calculated in, because these smaller values can be calculated much more quickly than the larger values. Now, this is, as I said, a brief introduction, but I would just want to show you one more thing, and that is where this can cause you problems. Okay? Because you can't just automatically put par inside of every for loop that you ever write and expect your code to run faster, because there are some challenges to this. And to illustrate that, I am going to do one of the simplest things possible. I'm going to set a var I equal to 0, and then I'm going to write a for loop that goes from 1 to 1,000,000, but I'm going to do it with a par. And inside of this loop, I'm going to do something really simple, increment I. And when I'm done, I'm going to print line I. Now, if you look at this code, it's pretty easy to see what you would expect that it should do. And in fact, if I get rid of the par, it's exactly what it will do. I starts off at 0, and 1,000,000 times I'm going to add 1 to it. So when I print it at the end, I should get 1,000,000. In fact, we can verify. Let's just go ahead, take out the par for a second, and run this. And sure enough, I get 1,000,000 here. But now, what happens if I put in the par? That's not 1,000,000. Neither is that. And neither is that. That one's kind of close to 1,000,000, but it's one of these things. For example, imagine this is your bank account. You really don't like it's kind of close to what it's supposed to be. You kind of want it to be what you're supposed to have in there, especially if, in this case, they're underestimating. The details of what's going on here are a little bit more complex, and that we'll wait until part 2 of the book to describe them. But this is what's called a race condition, and it basically occurs because you have multiple threads trying to play with the same value I all at the same time. And there are lots of ways to get around this, but the reason I want to show you this is to make sure that you realize you can't just stick par into every for loop you ever write. And it's mainly if you have mutable memory. If you don't use vars and you don't use things like arrays that are mutable, you actually pretty much can get away with putting par in just about everything. It's only if you have mutable values that you have to start worrying about it. But we'll come back and we'll deal with this in a lot of detail in the second half of the book. You can feel free to play with it some and see what it's like until then, and maybe you can use it to make some of the programs that you run go a little, or that you write in the first half of this book, go a little bit faster. So when we come back for the next chapter, we'll be talking about text files, and we'll use that to analyze all types of data sets without having to throw them in as standard input. That's it for now.